We're going to learn to solve two-step inequalities that are integer-based or with integers. We're going to look at the steps that are involved in solving this type of inequalities, and then we're going to apply those steps in solving some examples. The first thing you want to always do is to isolate the variables as we do with equations, and then we solve them. And if the variable is on the right side, we want to move to the left side and switch the inequalities. So when we switch, we're going to reverse using this method here. So if it's greater than, we switch it to less than. If it's greater than equal to, switch to less than equal to, and vice versa. One important thing to know is that the sign on the numbers don't change. It's only, so that means if the number is positive, it doesn't change to a negative. If the number is negative, it doesn't change to a positive. The only thing that changes is the inequality sign. So now we have this equation here, 7x greater than 3x minus 16. So we're going to isolate the x. I always like to move the x to the left hand side if possible. So I'm going to take the x out of here. So I'm going to subtract 3x here, subtract 3x. So 7x minus 3x, that's 4x greater than negative 16. Now we divide both sides by 4. And so x is greater than negative 4. So I'm going to put on the number line. So this is negative 4. This is 0. So x is greater than negative 4. So we have an open circle. And that's how we represent that. Second inequality here, 6y plus 15 greater than 48. So I'm going to isolate the variable by moving the constant to the right hand side. So I'm going to subtract 15. So let's look at 48 minus 15. So that is 333. So 6y is greater than equal to 33. So you divide both sides by 6. You have 33 divided by 6. Let's look at that. We have divided by 3. So y is greater than equal to 11 over 2. And we can either write it in fraction or decimal. I like to use fraction more than decimal because fraction is more precise. And so what we're going to do here is we have 11 divided by 2 goes 5 times. 5 times 2, we have 10. And then we have a remainder of 1. So y is greater than equal to 5.5. Here's our number line. 0. This is 5.5. So greater than equal to. So we have a closed circle. Greater than equal to 5.5. Now we have 21 minus 10x less than negative 5x. I'm going to isolate the x, so I'm going to add 10x to both sides plus 10x. So 21 less than equal to minus 5 plus 10, that's 5x. We divide both sides by 5. So 21 over 5 is less than equal to x. So let's get the fraction. 21 divided by 5. 21 divided by 5, it goes 4 times. 4 times 5, it's 20. We subtract and we have a remainder of 1. So 1 over 5 is less than equal to x, which means x is greater than equal to 1 over 5. So let's draw this on the number line. We got 0. This is 1 over 5. X is greater than equal to 1 over 5. That's your representation. And then finally, we have 24 plus 9x is less than 12x. So actually, I'm going to change the the question, I'm going to change it to 24 plus 9x greater than 12x. Let's do it that way instead. And so we're going to isolate the x by subtracting 9x from both sides. So 24 greater than 3x. We divide both sides by 3. 8 greater than x, which means that we switch the variable and the constant, so we switch the x and the 8. So x is less than 8. So now we have 0, we have 8. X is less than 8. The only reason I chose the signs is I didn't want everything to be greater than, so you can at least see an example where we're using the less than inequality.